So let's analyze these three. Less the logarithmic, because we're going to talk about it, both of them, the exponential and logarithmic, in chapter 3. Okay? So let's continue with rational and radical. So a rational function is a function that has x in the denominator. This is not a rational function, or this is not a rational function, because it doesn't have x in the denominator. This is linear. So any function that has x in the denominator, I'm going to share my screen. Please choose from any function that has, not radical yet, any function that has x in the denominator. If you don't choose, I will. And we want to determine its domain.
33.
You want to look at 33. This one here, 6 over 2 minus x, perfect. So this is 33. On page 32, we chose f of x equals 6 over 2 minus x. Perfect, thank you. Can anyone tell us what could be the problem here? What should we worry about here? No. We're talking about domain and range. What could be the problem here?
It's a negative x.
No, negative x is perfect.
It can be simplified.
No, it can never be simplified. Very good. So it's very good. I cannot be more grateful for you to answer, because you're answering, because I don't know what to address if you don't answer. It's okay if you make mistakes. Why am I here if you know it all, right? So first of all, we cannot simplify. We wrote that. I no longer have that. The notes are there. I send them to you. You cannot simplify anything but factors. 2 is not a factor in the denominator. So thank you for saying that. Please, it's tempting. I know it's tempting. You cannot simplify these two, because 2 is not a factor in the denominator. The negative x also is not a problem in the denominator. What could be the problem? It's okay if you don't remember. I'm reviewing everything that you need in this class. You just have to review it after class and watch the videos and refresh your memory. Anyone would like to try again?
You don't have any points to plot, like the main and range?
Nope. So here's the problem with a rational function. This is a rational function because it has x in the denominator. Something with x in the denominator. It doesn't have to be x necessarily in the numerator, but it has to have it in the denominator. If it has it in the numerator or not, it doesn't matter. But it has an x in the denominator, it's rational. It's a number divided by 0. This is the biggest issue with a rational function. That is not allowed, because this is DNE. It does not exist. We don't have an answer for it. So 0 in the denominator is the issue with any rational function. So therefore, I have to write that 2 minus x cannot equal 0. I move negative x to the other side. When I move a term from one side to the other, I change its sign. So it's negative here, it becomes positive here, so x naught equal 2. In interval notation, we have to write the domain as negative infinity to without 2, union without 2, infinity. So 0 in the denominator is not allowed. Now, later on, we will talk about something like this, which is not this. So remember the number, I did not put 0 here, not 0. So the number in the numerator cannot be 0. So like here. So when x equals 2, we don't have an answer. for this function. 0 over 0, it's something else. So we call this undefined. So please remember, rational functions can be undefined because the denominator could be 0, and that's never allowed. Okay, do we need to look at another example of a rational function? Yes or no?
Yes, I'd like to see another example, please.
Okay, they are all the same idea I meant, but of course everything is different, as you know. So if we look, for example, at 49, 49 has g of x equals 2x over x squared minus 25. What could be the problem here? Because we are asked to find the domain. So what is the domain? Well, the domain is anything but 2. But in mathematical terms, I have to write it like this. It's an interval notation. From negative infinity to 2, not 2, union, in addition to, if you want, or again, not to infinity. So what could be the problem here? Where is the starting point? Please say something. What should I write?
X squared minus 25 cannot equal 0.
Excellent. Can anyone factor this for us or tell us the solutions?
You move over the 25 by adding 25 to both sides.
Correct, that's one way. And then?
And then you square root both sides to
Yes.
get rid of the exponent.
Excellent. How many solutions do we get before you say anything? How many solutions?
2.
Exactly. I didn't want
Plus
to.
minus 25, right?
Minus 5, you mean? Yes.
Oh, 5, sorry, yeah.
Good. How do I write the solution for this? I was hoping for this situation, which is the same thing, and the factored form of x squared minus 25, which is perfect. This is perfect. This is perfect. I love that. If you want to factor, you do this, and you still get the same thing, plus or minus 5. How do I write the solution? Now, careful. So we have 2 elements to eliminate. Negative infinite, negative 5, not negative 5. Union negative 5 to 5, not 5. Union 5 to infinity. Any questions? So this is how we address the rational functions. This, as I said, later. Let's take a look at the radical. So any radical function with an even index, if the index is even, like square root, the 4th root, the 6th root, and so on and so forth, have to have 0 or positive underneath the square root. Any odd index, what do I mean by that? The cube root, the 5th root, and so on and so forth. Anything goes. No restrictions. So you could, and I could, edit here, radical functions with odd indices. Friendly, friendly, friendly. I never have to worry about a polynomial. It's defined everywhere. I never have to worry about the exponential everywhere. And I never have to worry about the radical function with an odd index. But if it has an even index, I do have to worry about it. Can anyone choose any radical function from this list that has an index that is 2, 4, 6, 8, any even, so we can find its domain?
Number 45.
Number 45. Let's take a look. Where are you, 45? I see it. Very good. So we have g of x equals the square root of 4 pi plus 5x. Again, let me clarify. When we are asked to find the domain, write the domain, ta, 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 in interval notation, then graph the domain. There is no need to graph the domain. We're going to graph the entire function later. So what are we asked to do? So when we're asked, one more time, just to make sure, when we're asked to find the domain of a function, we're simply asked, what are the x values you can plug in this function? We're not doing anything to the function. We're only asked the following question. What can you plug in? So here, what can you plug in? Anything but 2. Here, find the domain. What can you plug in? The answer is anything but positive or negative 5. What am I asked here? What can you plug in? Don't touch the function. Don't do anything. This is not what we're trying to do here. It's a simple question. What can you plug in? I don't know yet. So because the index is 2, so this signifies index 2. By convention, we don't write it. So because this quantity, whatever it is, which is this quantity for g of x, 4 plus 5x, this has to be greater than or equal to 0. That's what it says. You cannot take the square root from a number that is not positive or 0. So that's all I'm asked. What can I plug in? I'm not, again, students ask, well, what happened to the radical? What happened to this? What? No, we are not doing anything to the function. This is just an analysis. What can I plug in that exists, that makes g to exist? Of course, I move 4 to the other side. It becomes -4. I divide both sides by 5. And I read this and write it in interval notation. Domain starting with a bracket because of the equal symbol at -4/5 and going all the way to infinity. Again, we did not do anything to the function, but if you ask me, what can you, or you can say, you're asking me, what can you evaluate it for? I will say only between numbers -4/5 and infinity. If you ask me to plug in -10, I'll say, I'm sorry, I can't. -10 is not in the domain. 5 times -10 is -50 plus 4 is -46. I cannot take the square root from -46 and give you a real number. So I'm sorry. Ask me something else. Ask me to evaluate the function, but choose numbers here. If you say 0, yeah, I can. The square root of 4 is 2. It's not plus or minus 2. Be careful. This is a different story. Any questions about the domain? Are we okay with this? Can we move on?
I'm good with it.
Okay.
Yes.
Perfect. Excellent. I wanted to look at a word problem here. You can always stop me. It's something about incidence of breast cancer. We have a function here. Ugly. But they already graphed it for us. The following graph approximates the incidence of breast cancer, I, this is I, the function, the y value, per 100,000 women as a function of their age, x, the independent variable, the dependent variable, in years. The equation is given to us. Use the graph to estimate the domain of I of x. Can anyone roughly estimate the domain of I of x? I'm on page 5 and I will write it down.
25 to 100.
25 to 100, perfect. So this is problem, what was it? So I can write it, 63, yes. And this is on page 33. And the domain of this function, perfectly, we estimated 25 to 100. It could be 100 and a little bit, but it's perfect. Good. Use the graph to estimate the range of this function. Can anyone help?
Zero to like 450.
So the range. Yes. You said 0? I didn't hear the 0. Sorry. 0 to 450. So what does this mean, 0 to 450? From 0 to 450 incidents or number of women out of 100,000 that get, according to the function, that get breast cancer. What 10-year age interval sees the greatest increase in the incidence? So it doesn't say to find the maximum, but if it says, let's say, to find the maximum, what will you say the maximum is? At what age it appears to be that?
80.
Yes, it appears that the age of 80, unbelievable, women still get breast cancer. Okay, the age of 80, it appears that about 450 out of 100,000 women get breast cancer. No, this is asking something else, and this is where calculus comes in. So allow me to copy this graph roughly. So let's take a look at something like this. So remember what we looked at last class? I still have it here. I didn't put it in the bin yet. So last class we were talking about the average rate of change between 2 points and also the instantaneous velocity. Okay. The instantaneous rate of change. Not necessarily velocity, can be anything. Okay. So now this is the graph. So obviously here, the rate of change is 0. What is the slope of this line? 0. Here, the slope of this line, I don't care what it is negative. So in certain points here, I am going to choose a few points, and I am going to draw a tangent line to the best of my ability to the graph that I have here. Which of these points has the most acute, the highest possible slope? That is where the function increases the most. So this one has this slope, the next one has this slope, the next one this slope, and then it kind of starts leveling off. So this is the slope here, not too steep. This is the slope here. Much more difficult to hike on it if you want. This is the most difficult one. The steepest slope possible for this graph, because later on here starts leveling off, and it gets closer to and closer to 0. So the instantaneous rate is the highest where the slope is the highest of the tangent line. So not here, not here, somewhere here. That's where it increases the fastest. And we have to find that 10-year gap, if you want, or portion of the domain. So what will you say? Difficult. It's difficult to figure it out from the graph, but I would say somewhere here, because the slope here is this, the slope here is this, The slope here is this. So I'm guessing somewhere here. It accelerates the most. Right here. What 10-year age interval sees the greatest increase in the incidence of breast cancer? And here will be the decrease. But what will you say? I am tempted to say this area between the age of 50 and the age of 60. Anyone understands this? This is very similar to what we talked about last time. The rate of change. So, and basically the difference quotient. See here, the rate of change is this. The rate of change is this, the slope of this line, the slope of this line, the slope of this line, and levels off. But in our example here, this is the steepest. No, this is not the steepest. This is not the steepest. This is not, this is not, this is towards 0 if you want. This is the fastest rate of change, where the slope of the line is the highest. Okay, I think we beat that to the ground, I hope. Good. Moving on. I'd like to continue with the slope and lines and linear functions. And again, this is review, but I'm covering everything that we need. So I'm going to jump to 44. So this is R.4, and I have to stop my video.